Hello and welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 105, construct binary tree from preorder and inorder traversal. So for this problem, you're given two integer arrays, preorder and inorder, where preorder is the preorder traversal of a binary tree, and inorder is the inorder traversal of the same tree. And you need to construct and return the root of the binary tree. So for this problem, you need both the preorder and inorder traversal because you can't make a tree when you don't display the null nodes. You can't make a tree from just the preorder or inorder traversal. That's because if you in a preorder, so you go in preorder traversal, you go root, left subtree, and right subtree, and so you know the first node is the root, but you don't know how long the left subtree and right subtree lasts. Like this 9 and this 20 could be part of the left subtree. You can see in the picture that the 9 is the only node in the left subtree, but you don't know that from looking at the preorder traversal. It could last, it could be however many nodes. So you have no way to know when to stop trying to build the left subtree and the right subtree. So and the same thing for the inorder traversal. In the inorder traversal, you go left, root, and right. And you know that this 9 is the node all the way to the left, the bottommost left node, but you don't know what this 3 is. It could be another left node, or it could be the root, or it could be, you don't know what it is. So you need both of these together to give you all the information that you need. So the preorder traversal will give you the position of the root. So you know in a preorder traversal that the root is always the first thing, because that's how you do the preorder traversal. You go root first. So the preorder gives the position of the root. And then once you have what the root is, so the root is, it gives you the root. So once you know what the root is, you can use the root node to give you information about where the left subtree and right subtree starts in the inorder traversal. So you find the root in the preorder traversal, which is the first node. Then when all the nodes are distinct, if there's no repeats, then you look for the node of the root in the inorder traversal array. And so because inorder traversal goes left, root, right, you know that everything to the left is the left of the root is the left subtree, and everything to the right is the right subtree. So in that way, you can, so the inorder gives you the length of left and right subtrees. So, so, uh, so basically, you know that you now you have the root and you have the left subtree and the right subtree, so you can build the correct nodes from that. So your you have your new preorder. So you have your new preorder uh, traversal array, and you have your new inorder traversal array. So you have your preorder that gives you your root. So your root is 3, and then your inorder is going to be 9 and for your left, and your left is going to be 9, and then your right is going to be 15, 20, and 7. So you don't know where to put those things in the right, but you will give your new preorder will be now you take away your root because you've already visited your root. So your new preorder is going to be for your left is going to be 9, and your new inorder is going to be for your left is going to be 9. And so that's how we get this 9. And when you visit it, you put the 9 there. And for your right, your new preorder is going to be your new preorder is going to be 20, 15, 7 for your right, because you know that your left was one node, and so your right needs to be all the rest. So your left and your right, and so your inorder is going to be 15, 20, and 7. So now you have put your left right here. So now you need to do your right. Well, you know that your first node in your preorder is your root. So 20 is your root. So you put a 20 here. And then you look for your 20 in your inorder. And this is your left. And this is your right. And so you so in your next left, so your next right for your preorder, you give it 15 and 7 because you got rid of your root because you already visited that. And then your inorder, this is for your, oh wait, this is for your, we need to do, so we have the left first. So we need to do the left. So your left is one node and your right is one node. So your left preorder is 15, and your left in order is 15. So you put a 15 here. And then, because this is your first node in your preorder, and then your right preorder is one node after your left, which is 17, and your right in order is to the left, to the right of your root. So that's 17. Oh, it's not 17, it's 7. Sorry. 7. 7. And there you go. You've made your tree. So at the end, you basically, when these arrays become empty, you return none. So you would return none for all of these. So, and that is how you would construct your tree. So basically, you're doing this recursively. You are using your preorder traversal to find your root, which is the first node, and then you find the same root in your in order, and that breaks it up into left and right areas. And you pass those left and right areas into you use those for the next node. So you use your left and right as your new preorder and in order traversal. So this is the left here. This is the left, and this is the right. And you use those for the new preorder and in order, so you can do this recursively. So let me show you the code. So the first thing you need to do is take care of the base case. So the base case is if there are nothing in the list. So if not preorder or not in order, if one of those is empty, then we're going to return none. So that will give you an empty node. Otherwise, you're going to get the root node. The root node is going to be a tree node where the value is preorder, the first thing in the preorder array. And that gives you the root. And then we're going to call mid our index of our root in our in order traversal. So we're going to look for our same root value in our in order traversal. So we're going to find the index of root.val in our in order traversal, and that gives us our mid. So our left length of our so the left side of the tree is going to be from the beginning of our in order array to our mid. So in Python, the in value in the slicing is exclusive. So it's going to go from the beginning right before the mid is going to give us the length of our, so the length of our in order to our mid is going to give us how many nodes our left length is. And so then we're going to do, now we're going to construct our left node and our right child, our left child and our right child. So root.left, we're going to recursively call self.buildTree. And we're going to pass it our new preorder array. So our new preorder array is going to be our preorder array. We're going to slice it. So we're going to start. So remember, we took the root from the first position. So that's the zero index. So we took it from the zero index. So we know that we need to exclude that zero index from the new array. So we're going to start at 1. And how long is the left? So this is the left subtree. So how long is the left subtree going to be? Well, it's going to be the length of the length of the left subtree, the left length. But we need to start at 1. So we're going to go from 1 plus the left length. So we're going to go until the left length. Now we need to build the in order array, and that array we are going to need to give it the left subtree in order traversal. So the left subtree is from the beginning up to mid. When we find the root, so we're going up to the root but not at the root. Right before the root is our in order. So we give it that. So that's going to be what we pass to root.left. And root.right, we're going to give it we're going to call the build tree function, and we are going to give it our preorder array, but this time we want to start where we left off with our left length ended at 1 plus our left subtree ended at 1 plus the left length. So we actually want to start there. So we start at 1 plus the left length. And we're going to go to the end of the array. So that part is our right subtree. And we're going to pass it our in order. And our in order, we're also going to start from, so we ended at, we gave it we ended at the mid, so we're going to start at mid plus 1, and we're going to end at the end. And at the end, we're just going to return the root that we created, and this should give us our tree. So we're going to run this. So we ran this, and it's giving us the correct answer, so let's submit. and it was accepted. So this is how you build a tree from the Inorder and Preorder traversal array. So this algorithm will run in O of n time, where n is the length of the tree, the number of nodes in the tree, and it's recursive, so the space complexity will be O of h, where h is the height of the tree, and if the tree is balanced, it will run in log n time. Otherwise, if the tree is skewed, it will run in O of n time. So thanks for watching, and I'll see you in the next video.